In normal reaction time situations, let's say in 1950, you had, or even through 60, you had a stimulus, some time period passed, and you made a response. So this is a timeline. Okay, stimulus, time goes on, and I make a response. So that is, this whole time period is called what? It's going to be reaction time, right? So that's how I measure reaction time. Stimulus until I make a response. So then somebody got smart and said, okay, if we're measuring cognitive processes, there is a time between when the muscle is electrically active and when I actually produce force. Okay, those of you who have had physiology or maybe in biomechanics, that's known as what? So from the time the muscle becomes electrically active and the fibers begin to shorten, you actually produce force and cause the limb to move. Does anybody know what that time period is called? Okay, I'm going to have to talk to Saminsky about this. So it's called electromechanical delay. And for obvious reasons, it's this time between this electricity getting into the muscle, calcium being released, and all these things happening, cross bridges forming and pulling the muscle fibers over themselves, that you have a delay in time. Okay, and that time is usually about 50 milliseconds, I mean, just kind of as an average. So from the time I first could monitor electrical activity in your muscle until the time you actually produce force is about 50 milliseconds. And that time period is known as electromechanical delay. So somebody realized, well, if we're using reaction time to measure cognitive processes, we want to take that electrical mechanical delay time out of the equation. Okay, so what they did was come up with this term. So I need one of these pointers. I go zzz. They come up with fractionated reaction time. Okay, and what fractionated reaction time is they take this interval right here and they divide it into what's known as a premotor component and then a motor component. Okay, so let's just talk about the motor component now. So the motor component is from the time that you can measure electrical activity of a muscle until the response. Oops. Okay, so that's that electrical mechanical delay time. Electricity is in the muscle, but we haven't generated force yet. All right, so that leaves premotor time. Okay, and premotor time, how could you define that?
The time it takes for the stimuli to travel up the spinal cord, be processed, and then sent back down to your muscle.
Right, so that's what's happening, but define it just in terms of reaction time. It's from the time of the stimulus until the muscle becomes electrically active. Okay? So now we've taken out this kind of mechanical part of the equation. Now reaction time has been reduced supposedly only to the cognitive components.